Yeah, thank you very much for this elaborate introduction. Mix up only is fine. Yeah, sure. First of all, thank you for introducing, and thank you this Bengali Literary Association for giving me this opportunity. So I will start as you told. I have been working in ISRO since December 2021. So before that, I have been working in analog devices as analog design engineer there. So I am basically from electronics only, as you told. So I was working there as a circuit design engineer in automotive electrification. So I will start my journey my schooling. Are you able to hear? One minute. Am I audible now? Am I audible now?
Yes, now you're
Yeah, maybe some glitch in the headphone. So actually, I will start with my schooling. So I have been in Kendra Vidyalayas from my childhood, and my father has a transferable job. He was working in BSNL. So I have been in 4 or 5 KVs from my class one. So it was a elaborate very big what you say experience in my life, going to different places. I have been in Port Blair also for 2 years. So after during my schooling also, as you know, Kendra Vidyalayas will always be in army areas. So we are always in this seeing now and then this army people and all those things. So generally I got a little bit of patriotic feeling from my childhood, and I wanted to join army. But the thing is, it didn't ended up, and I was more interested in this engineering. So I choose engineering after my class 12. So my dream was to get into some IIT or something doing mechanical engineering, but actually it didn't happen due to several reasons, and I ended up in a college like this West Bengal University of Technology. There under it was this Institute of Engineering and Management in Kolkata. So I finished my BTech there, and I have been like in college, as you know, like it will be during my BTech, it was you are forced towards these placements. So as you might all be thinking, this placements in some IT companies or whatever the job is. So, but I was not feeling comfortable, like not feeling to go into some company. So I got some in placements also. I got some company, but I was not willing to join. So then I prepared for GATE, as I found that it is one of the thing I can pursue. So I studied very hard. I have to go to coachings and all those things, and many other things to clear my concepts, because from my childhood, since I have passion of engineering, so I was more focusing on these practical aspects of electronics and all those things. So finally, I got this rank of 125 somehow, and I was very happy. And I got this call from all the IITs almost for admission, but and some PSUs also. I got offer from Airport Authority also, but that was a big dilemma what to choose. So then, since I wanted to pursue more, like study more in engineering depth, so I choose this institute of Indian Institute of Science, Bangalore. There, so there it was good. Like that 2 years I passed my MTech. So that 2 years was a remarkable journey in my life. So I learned many things. All like now what I am, almost many things I learned from that 2 years of my life. Not only in terms of studying or education, but extracurricular things also. Like there I used to play also, and I learned swimming also. There I learned tennis also, badminton also. Everything I learned there, and it was a remarkable 2 years journey. Apart from that, it was like after masters, like during masters only, I got this internship offer in analog devices as an analog design engineer. Though I didn't have much experience, but I joined there. I cleared the interview and then joined. I was the only person to get into that company in internship. So after that, they absorbed me and give me a replacement offer there, and I was thinking like I was okay with that, because there was the work was like, if some of you are from electronics, you will be knowing this op-amp design and all those things like automotive electrification. It was fully core electronics only. That in BTech we are not at all, like not we don't do. Like generally what we'll do is like we'll take it as a block diagram and all those things, and detailed analog design. And I chose this analog design because there are two kinds of thing in VLSI. You will have two kinds of things. One is digital, one is analog, and some are mixed signals also. So in digital, like processor design and all those things will be there. Processors what we design. So some of my friends are there in other companies doing in working very good in digital. But I chose this analog domain because I was more interested in some interdisciplinary kind of thing. So in analog design, you will have circuit design also, you will have control systems also, and each and every kind of engineering aspects that is there you will have. And it's a niche domain actually. Less people are there in this domain, core analog domain. So I have chosen it, and I was happy there. But after my BTech only, since this, as I told you, during my schooling times, I was interested in this in this patriotic feeling. As I told, I wanted to join army, but didn't ended up. Then in my during my MTech only, final year, after my placements only, I have written this ISRO exam. That time only, I was not prepared much. I was thinking it won't happen, so that's why I generally have given the exam during my days there. So after that, it was this COVID time. I passed out in 2020 there. So during the last 2 months, we are sent home. So finally, then I joined this company from and did work from home only. And finally, I was working there. I was very happy. My manager was also very good there, and everybody supported me. And I was also very happy in the working. Like I was working in that complete core domain of electronics, and that was like I learned also many technical things in office that I can proudly say now, because I have learned it. You can't learn unless you work on it. So those kind of practical experience I had, and in my company, and that was a very good remarkable journey. Then suddenly this ISRO results came out, and my name was there for interview. So then it was like a dilemma again, like to go there or be here only, because I was happy here and I was working well, and I had published a patent also there, and I was very well. It was a very big thing. Then the thing is, what to do? I was thinking. Then I thought, okay, I will try my best for the interviews. Let's see after if I get selected, because interview, as you all know, it's little bit of luck based also. Like even if you know everything, you may or may not get. That is that interview thing. A written you can qualify if you know things, but the interview is little bit luck, and if you have some luck, you can get or don't get. So I went prepared well, but the preparation was very tough that time. I thought that I will let me prepare my best for the interview, but the thing is, the preparation was very difficult, because in my office also I have to spend the whole day doing the work there. But after that, preparing for this interview was a little very much hectic job for me. I had to like then the interview dates were also there. Dates were also announced, and I was not completing my syllabus. And I have done masters, and then after masters, I have been working into some core domain of electronics. But in ISRO interview, as this was BTech based thing, so they will ask everything. If some of you are from computer science or not computer science, electronics, they will be knowing that all the BTech subjects that are in GATE, they will ask everything. So that was a huge issue for me. Like I have to know communications also, I have to know control systems also, and everything. So I was not getting that mood, like how to be there, like how to prepare for the interview. Then somehow I prepared I had to spend many nights also there and reading, and then finally I was there at the interview hall, and the interview was okay only, not very good, not very bad. Like they were happy with my job also. Like since I was doing a good job in electronics, they were happy. They asked some difficult questions also due to that, and some questions I was able to answer, some question not. So I was okay only. Like I was not sure that I will be selected there or not. So then I came back, and then this working. I was working there as usual. Then I remember that day, like October 2021. It was this Ashtami. That day evening, this result came out, and suddenly I thought got that my rank is 17 there, and I was definitely selected. So then that night we are like just going out for seeing some pandals and all those things in Kolkata. I was there that time, so I was very happy. My parents were also very happy, because as you know, being a middle class family, all parents and everyone, being a not due to ISRO, being a central government job and a gazetted officer, they will be very much pushing. But my father was very humble, and he never told me that you leave the job and go. He told whatever your decision, that is fine. So then, but I was sure that I wanted to serve the nation or something like that, because even in unlocked devices I was working. It was like I was working in core domain, but finally I'm working for an American company, not for the country. So that is the thing. So then I was somehow, the decision was very difficult, because my friends who were there in ISC, they were also placed here and there, like Nvidia, Samsung, Qualcomm, and all those things. None of them has left the job. They were there only. I was the only one. If I go out, I was the only one going out. So it was a very difficult decision for me to do, like what to do. It is very difficult. Then somehow I selected. I was thinking I was doing wrong or right to go to ISRO. Then somehow I informed my manager also there, during my giving my resignation. I told him that I have been selected in ISRO and all those things. He didn't told anything. He didn't told anything negative about it, because generally in private company, if you want to leave, they will tell, no, be here, I will give you more salary, all those things. Because I was leaving for the job where, like in ISRO, I will be getting lesser salary than what I was currently getting. And if I would have stayed there for more 3-4 more months, I would have got another hike, and my salary would have been doubled, maybe what I want to join in ISRO. So he didn't told. One thing I remember, he told that because as you know, in private companies, if you go to other private company, they will tell how much they are giving, we'll give you more, and then you stay here. So since analog devices and Texas Instruments, those are rivals, like working in the same domain, not rivals, like working in the same domain only. So he told me one thing: I am happy that you are not going to Texas Instruments. So that was one thing I took positively. It was positive only for me. Then somehow I decided left it. Then I faced many challenges during that time. My cousin sister's marriage was also there in December, like December first week or something, and my joining was in December second week, like that time. Not second week, December third week or fourth week. So I was in my notice period. I can't take any leave or anything or something. And in ISRO, before joining, you have to do medical. So that medical also you have to do from your state, or you have to visit some centers. But it was very difficult for me, as in notice period, as you know, I can't take leave. If I take leave, that notice period will be extended by that amount. But my manager was very helpful. My manager and other people also there was very helpful. They left me before my ending of notice period only. There was 2 months notice period, but they left me in 1.5 months only. And after that, I came in Hyderabad and then joined here. I was internally, I was very much still I was thinking I was doing right or wrong, but somehow I was feeling that I am doing correct only. I want here, but somehow it was there that I was doing right or wrong. Then I joined here, and here being a, like, apart from technical, it's a central government organization. So it will be, the administration will be pure government kind of structure and all those things, and everything will be paperwork. It is not online, or as in private company it is online. Here everything paperwork we have to do. During my joining, like I have to fill maybe 100 of papers for each and everything. Like there will be some verifications also from IB and all. other intelligence organizations. So for them, we have to fill the complete form by hand. It is not, you can't take Xerox. So we have filled like anything that 1-2 days after joining. Then somehow I got the posting, and here I have been working. So after coming here in ISRO, finally I landed up in ISRO. Then I will explain that life in ISRO here. So in ISRO, the thing is, we are titled scientist slash engineer. So there is nothing written that you are scientist of electronics, you are scientist of mechanical, you are scientist of computer science or anything. It is nowhere mentioned. So once you are inside, it's like you are scientist. So you have to do some, you are supposed to do some interdisciplinary work. And as I told, I was interested here to do interdisciplinary work. So I was happy here. After joining, I was very happy that so much exposure is there, and so much like you can learn anything, you can do anything, nobody is going to stop you. You can propose your own ideas and do things. There is nobody there to stop you. So that is the thing. So I was happy. So now the thing is, mostly people outside, they will know ISRO in terms of, like, say now this Chandrayaan 3 launch was there. So everybody like, there was a very big hype. So everybody was knowing ISRO based on this interplanetary missions, like you are going to Mars, you are going to Moon. But the thing is, ISRO was not like, apart from the interplanetary mission, there are many things ISRO does that are like that are not hidden, but that are not much explored by people. Like outside people doesn't know. They should know, but they are not knowing, maybe due to many reasons are there. So the thing is, I got to know some since I am in remote sensing, I got to know some new things that I didn't have known or didn't have imagined previously. So because I was working in core electronics domain and not outside it, like what you read in books and all those things, that is different, and what you know from industry, that is different. So now I will tell you, based for ISRO, what are the things. All might be knowing, but some details I will tell. Say in ISRO, one is this interplanetary mission, as I told, that are there. Apart from interplanetary mission, ISRO has communication satellite, navic satellites, and some remote sensing satellites are also there. And apart from that, this human mission is also coming up recent now, this Gaganyaan mission. So if you go to the base, like in ISRO, ISRO started during 1969 or some that time period. So that time, Professor Vikram Sarabhai, he started. His vision was there, and his dream was there to develop the nation in space sector, and also atomic sector, and many other things he has done. He has done a vast majority of. He has dreamt India to go to the heights, but the thing is, so his main concern was, like, we are starting at the end of 1960s, and USA has landed, like NASA has landed in the moon in 1969 only. So interplanetary, they have landed human, not just a soft landing or something that they have done previously only. They have landed human. So there was a space race going between this USA and Russia. So as a result of that, there was human landing in outer space in like nearest cosmic body, that is our moon. So the thing is, India's goal was never to be to beat NASA or to beat any other country. India's goal was, like, Sarabhai's main goal was very simple. He was like, space should be utilized for the benefit of citizen. So the benefit of citizen means, like, space should be utilized in such a way that you can reach the farthest, like remote to remotest villages and all those things. So with that vision, ISRO started. So initially there was very many issues, like rocket science has many. It is a common thing that it is a rocket science. Rocket science is the most complex thing. But the thing is, there are many difficulties. That time they were struggling during Professor Kalam time and all those things. They were struggling to build a 3-inch diameter rocket. But now you see this PSLV 3-meter diameter rocket we are launching. So how vast, like how dynamic these things have changed, and how advancement of technology we gain. So, and another thing is like now we can Google anything. Like BSLV, if you want, you Google it, BSLV, you will get all the details, almost all the details. But at that time, if you know, like there were very limited sources of information. Theory information will be there, but practical informations won't be there. And NASA and these like other space organizations won't share the information with other countries. So it was very difficult challenge, and all these great scientists, they have done it. They have managed to do. They have managed to develop the engines. They have managed to launch finally. And I will tell you a story later. What is the culture? How was the culture of ISRO that time during Kalam's time? But apart from that, now let's see. Like as I told, communication satellite, Navig satellite are there. So communication satellite is just a. It will be a. If people are there from electronics, they will know electronics or electrical. It is just a transponder. In layman term, it is just like it takes the signal, it gives some gain, and then send the signal back. So it will be placed in geostationary orbit. If people are there, they will be knowing like there will be three kinds of orbit like LEO, MEO, and GEO. So LEO is the low Earth orbit, 600, 700 kilometer of height from the surface of the Earth. And GEO, as you know, if you place some satellite in GEO, it will be stationary with respect to ground. If a satellite is there that is seeing the seeing India, that will continue keep on seeing India only. The relative velocity between the satellite and the Earth will be zero. So it is around 36,000 kilometers from the Earth's surface. So those geo orbits are used for communication satellites to relaying the information. So by that, ISRO has done many demonstrated this TV at that time, 1970s, 80s. That time, TV was a very big thing. Like now you are getting because you have communication, but that time communication were not there. Remote villages don't have communication, so they have demonstrated this TV and some media communication, and that was a very big achievement at that time. So this is in terms of communication. Now also communication satellites are there. Everybody is using, and communication satellite, as you know, is a source of income for ISRO. It's a source of revenue generation because communication satellite, each satellite will have some say n number of transponders. So this n number of transponders they can lease to some company, private company like Tata, Sky, or some other Airtel, who have DTH services, or anyone. They can give the transponder and charge some values, like charge some price for that. So those things they can do, they can generate. But this interplanetary missions, there is not, it is not generating revenue. So that time it was not there. That's why interplanetary mission thought is only not there that time. Then communication, Navig is there. Navig I will explain. Before that, let me tell you remote sensing satellite as I told. So previously how, like long back, ancient times, so how will you make the map of some place? Like people used to travel in ships, like map of US and all those things. US was not there. Columbus discovered US, like America that time. So map was only not there. So how to make map? People used to travel that path and then they used to map it. So that is called cartography. So now remote sensing satellite is sensing something remotely. So remote sensing satellite, you can have a very good camera in your satellite and you can image the complete Earth surface. Like Google Maps, if you see, there you can see the satellite images. So by that you can map everything, the complete region, complete India you can map, you can get the roads, rail networks, road networks, and whatsoever, everything you can do. So remote sensing satellites also, there are basically three kinds of sensing. Like it's basic physics like class 12 physics only. So if you are in optical domain, optical means this wavelength that you can see in complete electromagnetic spectrum. So wavelength that you can see, that your color comes, that is the wavelength that you can see. So in that wavelength and some nearby infrared or something that you can't see, but that is optical only, those are called optical remote sensing satellites. Now if you to a go to frequencies like in the electromagnetic spectrum only, if you go to frequencies like 2 gigahertz, 3 gigahertz, or more like 9 gigahertz kind of thing, that range is called microwave. So that microwave range is there, that in that range also you can do remote sensing. So in optical, what is the thing, like sun is there as a source. So sun light comes, hits the earth surface, and you are getting the reflection. As normally how your eye sees the reflection from the object only. So sun rays are coming, that is hitting the earth surface. You are sensing that radiation from the earth surface, and you are seeing that image. That is called general optical remote sensing. And in microwave, what is there? It is a kind of radar. So what it does, it generates its own signal. Like say some C-band radar is there, some 2 gigahertz, 4 or 4 gigahertz something. So that 4 gigahertz signal, the satellite will only send, that will get reflected from the earth surface, and you will capture it, and from that you will get the information of the earth surface. So that is microwave. Now these two are like, you have some source and that is getting reflected and you are receiving something. Now comes thermal. Another thing is thermal, that is in the IR range, like 10 micrometer or something like that sort of range. So in thermal, there is no source. Like all have read in first year or maybe something called as blackbody radiation. So in blackbody radiation, each object that is has some temperature will emit some radiation always. So that radiation, if you capture from thermal, like from some thermal sensor, that is called thermal remote sensing. So this three kinds of satellites are there. Like optical, as you told, there is one thing is cartography and another thing is resource monitoring. So if you have a forest, how big is the forest, and how big is the urban area, how big are the rural areas, and everything. Like governance also can be done with that. So that is called optical. That also we are at the, like we matched what global standards are. And next come microwave. Microwave also we are at the top notch in microwave. Like this, if you can search this, US4 is also there, RISAT series is there. Many radars we have launched. Now in the radar, if I go in little detail, like we have some synthetic aperture radar. So that was the technology. Initially, it was used by NASA. They were not sharing the technology, but we developed it indigenously. So that is a remarkable, like engineering marvel. So the thing is, if somebody is there from electrical and electronics, they will understand that in radar, to increase the resolution, if you have to see 1 meter resolution or very fine resolution, if you have to see, then you need a very high gain, and high gain will given by a very big antenna. In satellite, since you have to launch it also, so with some launch vehicle you have to launch it and then it will go. So if you have a very big antenna there, it is not feasible. So if it is not feasible, how will you get the gain from that 700 kilometer above the earth surface? So a new technology is there, that is like, since satellites are moving, always moving, so you use the velocity of the satellite to increase the gain. Because see, if you have to get big antenna, that means say 1 kilometer length antenna, you can't put in satellite. But see, if you have a velocity, and if you have a point in earth surface and your satellite is moving, so you are seeing the point for a longer duration. So say if you are with reference to the point, if you are seeing the satellite for 1 kilometer range, then effectively synthetically you have created that aperture 1 kilometer. Actually it is not there in the satellite, but you have synthetically created that is the basic concept of synthetic aperture radar that is being used in this microwave remote sensing. That we are at the top notch only, we are at par with the global standard, maybe above also sometimes, and that is very good thing. Now comes this interplanetary mission. Now since they have generated so much revenues and all those things, India has also grown, India's GDP also grown. Now they have planned for this interplanetary mission. So interplanetary, first this Chandrayaan 1 was there. In Chandrayaan 1 there was a plan of one orbiter, so it will orbit the moon surface, and it will be a satellite of the moon, you can say. So satellite of the moon, it will take images, or some sensors were put into that. And one impact probe was also there, like that will crash land on the moon surface, and that will give some data about this place where it impacted. So there was a thing like, we have put a flag of India into that impact probe, and that flag is there in the moon surface now. So that has impacted. Next came this Mangalyaan. Mangalyaan also, it was very far Mars, as you know. it takes long, like days or months to reach there. So if you go directly also, so it will need a very huge fuel. So India has developed one, not developed, like utilized one procedure, like it will use the Earth's gravitation pull to accelerate it, and then finally do into trans, like, or you can say helio orbit, and then it will reach the Mars surface, and then uh, in the Mars gravity it will revolve. So it was just a orbiter, small payload, and we are successful in demonstrating that thing. So it requires actually very huge amount of flight dynamics. All calculations had to be done, and all, like if you know, like you shouldn't hit any asteroids or anything. Also, that calculations also need to be done. And when Mars is at which place, and when Earth is at which place, how will you launch, when you will stop, all this calculation, very complex flight dynamics is required, and that ISRO has achieved. After that, this Chandrayaan 2 was there for soft landing, but as you all know, it failed, and it crash landed. And after that, Chandrayaan 3, uh, it's a very huge, remarkable success of ISRO. So I will share one of my personal thing. During Chandrayaan 2, it was like night 2 a.m. or something when it crash landed. So that time I was in ISC only, and I was thinking, just for like that, we are at lab only. We are doing some assignments. We are very hard. We are spending nights for assignments there because you have to complete it somehow. We are learning also. We are doing. So we played it in a projector in our some gallery, and we saw it. And Chandrayaan 3, when I am seeing, I am at ISRO now. So it was a very, I felt very happy when I saw it now. So this is the thing. And next is this Gaganyaan mission. So Gaganyaan mission, we are planning to demonstrate, like send some person to move, send some person to the space, not in space means like above 100 kilometer is considered as space. There we'll send them, and then the main objective is bringing them back also. Not only sending, you can send anyone, but bringing them back is the most challenging task. So for that, human rating of the rockets were being done. So ISRO is working on it, and I have some experience in human rating before ISRO also. Since I told I was in analog devices and I was working in automotive electrification, so there I have been working in electric vehicles, battery management system. So there actually, this is some learnings I got. Previously, I was not knowing. Being a student also, or being, even if you read, you won't be knowing all this. The thing is, I got to know that since life is involved, so if you are designing some circuits for this battery management system, and in the vehicle some person will be there, so some life risk is there. So if some life risk is there, rather than features, you concentrate more on fail-safe design. So your design shouldn't fail. I will give you a small example. Everybody of you know that airbags are there in car. So airbag, what is the function feature of airbag? Feature of airbag is when you hit something, it should deploy. But when you design, the designers of airbags or the control system that actuates the airbag, most important task is, if you don't hit, if you are not hitting anything, you are moving at 100 km per hour, and that time your airbag shouldn't deploy. That is the fail. If it fails, it will deploy. So rather than the feature, it's more important that it doesn't deploy when you are at 100 km per hour. So that is how these fail-safe designs were there. So when we are doing circuits in, like, as you know, you are all in BTech, you will be knowing that in circuit design, features are more important. We will be also doing, like, you are getting this feature, you put an Arduino there, you are getting this feature. But rather than that, if that Arduino is fail-safe or not, that you have to ensure first. So when we are used to do some op-amp design or something, like, rather than the feature, we are more of the circuitry will go to make that circuit fail safe. So that is the thing, that is, like, I can tell you small difference. Another is, you know, this Philips some bulb, or in tube light it will be there, na? Choke it will be called electronic choke or something. So what is the difference between a Philips choke and a Chinese choke? Simple, it will be very cheap. Philips choke will cost 200, 300, and Chinese choke will cost around like 50, 60 rupees. What is the difference? There is no, in feature wise it is same, but Philips choke, it is fail safe. You know, Chinese items will fail uh, any time. It can fail any time. It is not reliable. So how can it is reliable? How can we can make it reliable? Like say if you have a resistor, say 10 10 ohm resistor or something, 10 kilo ohm you can say, whatever it is. So instead of putting 10 kilo ohm, if you put 2022 in parallel, so even if one fails, you will have a resistance. Otherwise, it will burn. No. So that Philips things will have 100 of that kind of redundancy to make it fail safe. That's why it is costing more. It is not that it is costing, company is charging more. So that is another factor, that company is charging more or whatever, that is business thing. But in terms of technical, it is also there. So for Gaganyaan, we are doing this fail safe and human rating of this boosters, rockets, and your crew module and whatever it is. So that is the thing. Now, as I told, these are the all the works. Maybe I have missed something, but I will tell you one small story of Kalam sir and this. That time Satish Dhawan was the chairman of ISRO. So. So when the first development was there, that was called SLV-3, Satellite Launch Vehicle 3. So during its launch in 1979 or something, exact dates I don't remember. So first launch, uh, so actually during launch what will happen is at T minus 8 minutes or something, computer will take over. Means computer will take over means there are thousands of parameters you have to monitor. So that you can't do manually. So you have to give it to a computer to run it. So this is called automatic, like automatic launch sequence. It is called. Till now it is there. Now also that will be like that. So T minus 8 minutes it was given to the computer. It has started. Then at T minus 4 minutes, what happened? It showed, computer showed, don't launch. So means some issue was there in the second stage. So in the second stage control system, some issue was there in the, some leakage was there. Then what Kalam sir did is he has a choice. He can do manual override on it and launch it or stop it. So he consulted some senior scientists there, and they suspected, yeah, some issue is there, problem is there. But then there was like they what you say, they assessed that even if there is a leak, we can do the launch. So then there was some decision taken. It is not one person, it was the team decision. Then it was put go for launch, and then it was started. First stage was completely fine. Second stage started spinning. At that time only Kalam sir was knowing that this will fail. So then finally it ended up into Bay of Bengal from Sriharikota. So that was the thing. Then next day there was a press conference. So in press conference, Satish Dhawan called him, Kalam sir, because Kalam sir was the mission director and project director that time. So he called him and told, come to the press conference. You just come. I will take over. You just be there. Then Satish Dhawan took the complete blame into himself only. He told that we failed this time. We'll after 1 year we'll learn from the failure, and then we can launch next time. So like that it happened. So that is a kind of leadership that you can say, that is a culture of ISRO. Now next year again that launch was there, exactly after 1 year or something like that. So again launch was there. That time everything was fine. T minus 8 minutes it started, computer took it, it launched. Finally it put the satellite into orbit, and it was complete successful mission. That time Satish Dhawan called this Professor Kalam sir. So he told, this time you take over the press conference. So that is the remarkable thing. Like when it is a failure, your boss, he is taking the responsibility, and when it is success, he is giving it credit to you. That is some good culture that is there from the beginning in ISRO. That here it is there still now, and that is a good thing. That's why there is a ISRO is doing this success. So this is what I wanted to say, and fine. If somebody has any questions, they can ask. That is there.
Right, sir. Thank you so much for that insightful, detailed experience about your life into ISRO and then your life in ISRO as well. It will definitely be an expansion of knowledge for all of us involved here. So before this event, we had noted down some questions from our participants that they would like to ask you. So the first question that we have is, as you mentioned before, also you had done some internships and you had published some papers as well, like FMCW radars for volume scattering from precipitation, and then you had done some internships at Indian Oil and then at Analog Devices. So, what would you say is the importance for both internships and papers, and is one more important than the other, or should we just maintain a balance between both?
What I can say is focus on the basic concepts more rather than papers and all those things. If you know the basic concepts, now if you have some, it is not like if you want to publish a paper, it is not like that. You work for the paper and publish it. That is not how it will gain you something. You work for the basic concepts or some ideas. You work for the ideas. Paper will automatically come. That is how it should be, but that is not there in my BTech time. Also, I have seen people like they are publishing papers but not knowing the complete depth of that. So that's what I will suggest, that focus more on your basics rather than publishing paper. And second thing is internship. What I felt, I have done two internships in my BTech time. One was in Southeastern Railway. As I told, I was interested in mechanical to join, but I got somehow in electronics. So I was fine with anything. Like if you are giving me work of like, since in mechanical, it will be like you will have to work in this sun, and like in Southeastern Railways also, when I was doing internship, I was like, we are taken directly to the points, like this how railway tracks, like this train changes its tracks, it will be points, there will be some actuators there, some motors will be there, we will go there, like he will take us, the section engineer will be there, he will take us and they will open it and show us, and we'll be standing in full heat that time. I don't have issue, but the thing is, if you do internship what you like, it's not that forcefully you are doing. If you do internship what you like, you will learn many things on it that you will not know when you are reading. When you are just reading a motor, you will not knowing how, like what is the practical implications of all those things. Like will read relays, but railways use relays a lot. They will use it for everything, making it fail safe. Like if your points are set to one track, your signal can't be green at that time, so that is controlled by relays. And now some solid state interlocking is also coming, that is called actually RRI, route relay interlocking. So all those things I was previously, by theory I was not knowing, but if you do the internship you will know it. So that's how I can say, like, do internship, go to the place where your your internal passion lies. If you do there, you will learn many things. Now some other persons were also there, they were not interested at that time when I was doing internship. They were not at all going, they were at the station only and we are going and seeing the points. But what I learned they can't learn, because they were not interested. It is not wrong, I won't take saying, but they can't learn. So go for those things where you are really interested. You will learn a lot in internship if you are doing in any company or anything, because what, as an engineer, you are designing something, finally it should have to work. So an industry, it will be working, so you can see the final product what is working. So seeing that also you will learn many things if you are interested. So that's how I will put it, like papers and internship. Paper also you focus on the basics, paper will automatically come if it has to come. Don't focus on that I have to publish a paper, like that.
Sir, if you could go back in time and give one advice to yourself while you were still in your first or second or third year doing your bachelor's, what would that be?
Advice, what I will tell, I could have taken mechanical. That is one advice I can give me, like, because I was more interested. Second thing is, like many things I have learned, many wrong things I have done, like took wrong decisions or something. The thing is, the advice is, if you are interested in something, you go for it. Don't think what is the repercussions. If you are interested to take, say, just for example I am telling, if you are interested in civil engineering, you know you will not get a job. If you take computer science, you will get a job. If you take civil engineering, you are not getting a job. Say, just for the sake of example, I am telling. If you are interested really in civil engineering, go for it. Don't think about this. That's what I will say to myself, because sometimes I have also taken some wrong decisions seeing everyone. But the thing is, I should have gone to what I was really interested. That's what I will say. That if you are really interested in something, go for it.
Okay. Thank you very much, sir. With that, we shall be winding up this session. I would like to extend my thanks to VIT Vellore and the Department of Student Welfare for allowing us to host this amazing event. And I would also like to thank Mr. Supantha Sen for taking time out of his hectic schedule to grace us with his presence and endow us with so much knowledge. It was definitely a pleasure having you, sir.
Yeah, thank you very much. Thank you.
With that, we'll be winding up this session. Thank you to everyone who has joined, and we'll see you with the next event. Thank you.
Thanks.